All right, guys, it is time for my favorite section of the year, and this is trigonometry. Trigonometry, what does the word even mean? Trig, triangles, nometry is measurements. It translates into triangle measurements. And we're going to talk all about it. Now, trig is built on right triangles for the most part here. So if I have a right triangle, there's a lot of stuff that we can figure out. We actually know everything, every ratio about every triangle that you could conceive. Okay? So I'm going to start with a triangle that we already know. It's called a 30, 60, 90. Might be familiar with it. We've worked on it. And we know that every time you have a 30, 60, 90, that the side lengths are a multiple of 1, root 3, and 2. For example, if I had a different 30, 60, 90 over here, right, I have my 30, my 60, and my 90. If I knew that the side here was 5, right, that would mean, the short leg is 1 times 5. The long leg would have to be root 3 times 5, and the hypotenuse would have to be 2 times 5. These are all multiples of 1, root 3, and 2. Okay? Now, what trigonometry is a system where we have the ratio between any two sides of a triangle. And I'm going to show you examples of that on a 30, 60, 90 here. So the first trigonomic ratio that we're going to talk about is called sine. It's spelled S-I-N-E. That's the full word. But we pretty much always abbreviate it, or not abbreviate it, but shorten it to S-I-N, sine. So there is something called a sine ratio. And guys, someone just kind of made this up. They could have picked any two sides, okay? But someone said, okay, we're going to call it the sine ratio. And when we take the sine ratio, what we mean by that is the opposite side divided by the hypotenuse. Okay? So the sine ratio is opposite divided by hypotenuse. Now you might be wondering, what is this? That's the symbol theta. And theta almost always refers to an angle measure. Almost always. You see that in math and science. It's talking about an angle measurement a lot of the time. So what we're saying is that the sine of some angle measurement is always defined as the opposite divided by the hypotenuse. And what that means is if I were to take the sine of 30 degrees, the sine of 30 degrees equals 1 divided by 2. Let's break that down. So here's my 30-degree angle. The opposite side from 30 is my 1. Boop! The hypotenuse of this triangle is 2. This is opposite and hypotenuse. And what our sine ratio says is you take the opposite side and divide it by the hypotenuse, and that'll be what we call a sine ratio. So if you have a 30-degree angle, that ratio will always be 1 over 2. Look over here. The sine of 30, here's my 30, that would be 5 opposite divided by 10 hypotenuse. Well, what is 5 divided by 10? It's 1 over 2. It does not matter which 30, 60, 90 triangle you are working on. If you go to the 30-degree angle, the opposite divided by the hypotenuse will always reduce to 1 over 2. Always, always, always. It's always the same number. That's because all of these triangles are similar. Okay, the second trig ratio we're going to talk about is called the cosine. And this is usually just shortened to cos, C-O-S, but we always say cosine. And again, that is just a ratio. Someone said, okay, we're going to call it cosine, but instead of it meaning opposite over hypotenuse, it means the adjacent leg, and I don't write the L on there, but it's the adjacent leg divided by the hypotenuse. The adjacent leg divided by the hypotenuse. So let's look at our problem. Let's say we're talking about the cosine of 30 degrees. Let's go over here. So let me erase this junk. So the cosine of 30 degrees. You find the angle in question. The angle is 30 degrees. So we go to the 30-degree corner. And this is the adjacent leg. Remember, adjacent means next to or touching. And we do need to specify leg, even though I don't always write it. But this is the 30-degree angle. It is adjacent to two sides. It's adjacent to the hypotenuse, and it's adjacent to this leg. So when I say adjacent, I'm always talking about adjacent leg. This is the adjacent leg for 30 degrees. If I was talking about 60, this would be the adjacent leg to 60. It's the leg that touches the angle that you're talking about. Right now I'm talking about 30. That's the adjacent leg, and this is the hypotenuse. So if the cosine ratio is defined as the adjacent leg divided by the hypotenuse, for 30 degrees, that answer would be root 3 divided by 2. And it doesn't matter which triangle you pick. How about over here? If I said the cosine of 30 degrees on this, the adjacent leg to 30 would be 5 root 3, and the hypotenuse would be 10. Well, what happens when you reduce 5 root 3 over 10? That is also root 3 divided by 2. It will always be that ratio. It doesn't matter if it's the size of the sun or the size of your thumb. It's going to have that ratio if it's a 30-degree angle. The last ratio we're going to learn about today is called tangent, and it is shortened to tan, but we always say the full word. We always say tangent. Tangent of theta is defined as the opposite side divided by the adjacent leg. The opposite side divided by the adjacent leg. So let's take a look at that. What if we did the tangent of 30 degrees? So let's go up here. Let's identify these parts. If my reference angle is my 30, we go opposite, that would be the 1, and this is still the adjacent leg. So we're not going to use the hypotenuse. This is the only one that doesn't have h. So opposite divided by adjacent. That's what tangent is defined as. And this would be 1 divided by root 3. Now remember, we don't leave decimals in the denominator, and root 3 is a decimal, so we would clean that up, and we would say that's root 3 over 3. So if you were to type these into your calculator, these are the numbers that you would get. So let's talk about the calculator for a second, because it can be a little bit icky. So if we go to our calculator, look at this screen. We've got math. Do you see where it says RAD here? That means it's in radians. And we are not going to talk about radians just yet. We don't want to be in radians. So this is something you have to do on every calculator. They almost always default to radians. We need to, on my calculator, these are the school calculators, we hit Shift, Setup. It's on the menu key. Do you see where it says angle, radians? You must change that over to degrees. So I scroll down, and I'm going to hit degrees. That's F1 here. So now my calculator, when I hit Exit, look what it says at the top. Now it's in degrees. So now when I go over here and I type in sine of 30, whoop, look at that. It's 1/2, which is what we said it was a second ago. We can confirm all these numbers. If I type in the tangent of 30, look, that's what we got. Those are the ratios between those sides every single time. So the calculator is going to come in big for a lot of these problems. We need to be ready to use it, so make sure your calculator's in degrees and you know where those sine, cosine, and tangent keys are. Let's throw a little curveball here. What if we switched it up and we said, instead of sine of 30, just so you can see it, let's do the sine of 60. What if we changed it to the 60-degree perspective? Here's my 60-degree angle. What's across from 60? Right? It's opposite over hypotenuse. So we go opposite. That would be root 3. And the hypotenuse would be 2. So the sine of 60 degrees is always root 3 over 2. Go to your calculator. Type it in. If you type in sine 60, it's going to spit out root 3 divided by 2. That is the ratio every single time. So we learned 45, 45, 90s and 30, 60, 90s first because they're they're the ones that can be written as simplified radicals, as sometimes as rational numbers, 1/2, just a rational number. But they can all be written in simplified radicals and whole numbers. There's only one other set of angles that can do that. We're not going to talk about that right now. But most angles are these irrational numbers that cannot be written as a simplified radical. They can't be written with whole numbers at all. And so that's what we're going to be dealing with right now. So let's talk about a triangle here. And actually, let's just make sure we got the original properties down. Let's say we have angles A, B, and C. We're going to do a real basic problem right now. And you're going to see something like this on your quiz. Let's go real basic before we move on. Let's say we know two sides. We know that this side is 10 and maybe this side is 24. And I'm going to ask you for some questions. I'm going to ask you for the sine of angle A, for the cosine of angle A, and for the tangent of angle A. And then I'm going to ask you for the sine of angle B, the cosine of angle B, and the tangent of angle B. You have to know which ratio goes with which word. Like sine, you have to know is opposite over adjacent. And there's a key phrase here that I've always used, and it is Sohcahtoa. Sohcahtoa. Rolls off the tongue. Sohcahtoa. And all of our formulas, all of our ratios are hidden in here. Let's break it down real quick. So, S-O-H, that is the sine of theta equals opposite over hypotenuse. Cosine, C-A-H, that is the cosine of theta equals adjacent over hypotenuse. And TOA, T-O-A, that is the tangent of theta equals opposite over adjacent. And remember, every time we talk about adjacent, A is the adjacent what? Leg. Not the hypotenuse. It's the adjacent leg. All right, so keeping that in mind, let's try to answer these questions. Well, first we need that third side. If you know two sides of a right triangle, you can always get the third. So let's do some Pythagorean theorem. The GCF is 2, so I'm going to do 10 divided by 2 is 5. I'm going to do 24 divided by 2 is 12. And if you remember our triples, this would have to be a 5, 12, 13. So we know that this third side has to be 26. There we go. Now, we want our answers to be reduced. We want our answers to be fully simplified, but let's see what we can do. So we have sine. Remember that sine is opposite divided by hypotenuse, and it's angle A. So we go to angle A. We have opposite and hypotenuse. So this would be 10 over 26, which reduces to 5 over 13. Cosine of angle A. Go back, we're talking about angle A still. Cosine is adjacent over hypotenuse, right? It's Sohcahtoa. It's It's ka. Please, if you get this one right, it makes getting this one easier. It's C-A-H, not co. It's ka. Sohcahtoa. So A over H, that is not angle A. Be careful. This A is adjacent leg. Not talking about the angle. So, but this is talking about angle A. So we go to angle A. This would be the adjacent leg. This would still be the hypotenuse. That is 24 divided by 26. We reduce that, and that would have to be 12 over 13. And the tangent is O over A, which is opposite. That's the TOA, part of Sohcahtoa. Opposite divided by adjacent. We're still talking about angle A here. So what is opposite angle A? That's 10. What is the adjacent leg? That's 24. That is 10 over 24 must reduce. That would be 5 over 12. So those are all of our ratios for angle A. I'm going to do angle B really quick, but it's the same premise, just a different starting point. So angle B is the bottom right corner. So it's still opposite of over adjacent, but 24 is opposite of angle B. So the sine of angle B would be, the sine of angle B would be 12 over 13. Cosine is still AH. The adjacent leg, 10 is the adjacent leg, and 26 is still the hypotenuse. So that'd be 5 over 13. And then tangent of angle B, well, the opposite and the adjacent is just flipped from A, right? If I'm at angle B, here's my opposite, and 10 is my adjacent. So that would be 24 over 10, which reduces to 12 over 5. So there's all my angle B ratios, which notice they're a lot like our angle A ones, right? If I'm at angle A, whatever's opposite angle A is always adjacent to angle B. So the sine of angle A, which is opposite over hypotenuse, will always be the same as the cosine of angle B, which is adjacent over hypotenuse. Opposite from A is going to be adjacent to B. Same thing with angle B. Opposite from B is going to be adjacent to angle A. So that's one way you can kind of think about this stuff. All right, so that's a real basic situation. Let's talk about actually using ratios to solve problems. So remember, we know every ratio that could possibly exist. So I'm going to make up a situation. Let's say that we have a 20-degree angle, okay? 20-degree angle. If I type the sine of 20 into my calculator, and I'll show you as we do it. If I go to my calculator and I type in the sine of 20, right? Let's take a look here. We got sine of 20. It's going to give me a number. It's not as clean as like the tan of 30, but that's the number, right? If I scroll up to tan 30, look at this. Tan 30 is really just this long, messy decimal. The difference is that decimal for tan 30 can be written as a simplified radical. Not rationalized, simplified. So we take a look at this. That's the number. Do you think I expect you to memorize this number? No. And when we talk about ratios, we actually usually just write to the nearest 10 thousandths. The more you go, the more accurate it is. Like if you kept going, like that's more accurate, then that's more accurate, then that's more accurate. But the calculator even rounds the last number. So even if you write them all, you're not extremely precise. But when we're talking about ratios, specifically ratios, I'm going to almost always ask you to go to 4 digits. That's the nearest 10 thousandths. So that's 0.3420. So let's keep that in mind. So the sine of 20 is 0.3420. Well, what does that mean? That means if you have a 20-degree angle, right, and this is opposite divided by hypotenuse, equals 0.3420. Well, that means it has to be like over the number 1. That means if we go to 20, the opposite side would be 0.3420, and the hypotenuse would be 1. That's what that means. Okay, what if we type in the cosine of 20? Let's go do it real quick. I'm not going to show you, but go to your calculator. Type in the cosine of 20. Same idea. If I go to 4 spots, that would be 0.9397. 0.9397. Remember, that is the adjacent over the hypotenuse. So we're saying adjacent divided by hypotenuse is 0.9397, which means it's like that number over 1, basically. So that means the adjacent leg would be 0.9397. And this is a triangle that would have a 20, and that means this would be 70. Every single 70, 20, 90 is a multiple of this triangle. Every single one. Let's do Pythagorean theorem on it. Let me show you real quick. If I do 0.9397 squared plus 0.3420 squared, if I were to type that in, 0.9397 squared plus 0.3420 squared. I type that in, I hit enter. I'll show it to you just so you can kind of get a feeling here. Notice it's 1.000045. That's because we rounded. If I had not rounded these numbers, it would have come out perfectly at 1. But that's basically the number 1. If we round our answers, then you're going to not have perfect answers. But it basically comes out to the number 1, checks out. That's a right triangle, guys. So what the point of this is we know every ratio for every triangle you could come up with. Test it out in your calculator. You could do 21 degrees, 22 degrees. You could do, 22.5 degrees. We know every ratio for every triangle that exists. So how do we use that information to actually solve problems? That's the big question. If we know all these ratios, how do we solve for missing sides? And that's the beauty of trig, is we can find missing lengths without having to measure them all, without having to know them all. Pretty amazing stuff. So let's go back to our 20-degree triangle. And let's pretend that we have a hypotenuse that's 10 units long. So this is what we got. So let's remember, let's pretend, what if it was a 30, 60, 90? We did this one a second ago. If this was 10, you would know that this is 5 and 5 root 3. That's because you have those ratios memorized. You know that the sine of 30 is 1 over 2, so you know you divide by 2. You know that. 20 degrees a little bit tougher. It's not as clean. Remember we talked about these are not clean numbers. They aren't, you can't simplify them, write them as simplified fractions and radicals. But I mean, yeah, how do you go from this to, how do you do that? Well, that's kind of hard to visualize. So let's talk about how we could do it. If I wanted to solve for this side, call it x, this is what we know. We know that the sine of 20 degrees has to equal the opposite side divided by the hypotenuse. So on this problem, that would be the opposite of 20 would be our x, and the hypotenuse is 10. We know that this must be true. And keep in mind, what was the sine of 20? Remember that this is like 0.3420. So what we're really saying is 0.3420 equals something divided by 10. Some number divided by 10 has to equal that ratio, because that must be the ratio for these triangles. Well, this is just an Algebra 1 problem now. Let's go back to Algebra 1 real quick. What if you said 7 equals x divided by 10? How do you solve that? Well, you multiply both sides by 10, and you get 70 equals x, right? So at the end of the day, if x is up high, all you got to do is multiply. Get it right your first try. Let's go. But it's not 10. It's not 7. It is 10. It's not 7. But we do the same thing. We multiply by 10. So you would get x equals, in this case, it'd be 3.420. Now, I don't want you doing it this way. I'm just showing it to you so you can kind of see it as decimals. You need to be thinking, even if you don't know the number, if you see sine 20, you need to be thinking that's a decimal. That's a number. That is a decimal. So this is what I would this is how it should look. If you're doing it for me on a quiz or a test, you would say the sine of 20 equals x over 10, and then you would multiply both sides by 10. If x is up high, all you got to do is multiply. Get it right your first try. And so x equals 10 times the sine of 20. That is actually the answer. And sometimes you leave it like that. Much like you might have an answer of 10 root 3, right? You'd leave it like that. That's the simplified version. This is the simplified version. But most of the time, I'm going to ask you to round. So then you type that in your calculator. You go to your calculator, you type in 10 times the sine of 20. And we already know it's going to be 3.420. So rounding rules are going to get kind of confusing. But for angles and for sides, you're going to round to the nearest thousandths really often. For ratios, this is a ratio, you're going to go to the nearest 10 thousandths most of the time. So different rounding rules for different situations. But we would know that this side is 3.420. All right, let's do this side real quick. What if this was our y value over here? I'm going to do it much quicker, but this is the angle. This is the adjacent leg and the hypotenuse. That's the leg that touches it. Well, what formula was adjacent leg hypotenuse? That was my cos. That is the cosine of the angle equals adjacent over hypotenuse. So the cosine of the angle, this is a 20-degree angle, equals the adjacent leg, we're going to call that y, over 10, the hypotenuse. If y is up high, all you got to do is multiply, so it's 10 times the cosine of 20. That's the answer, but most of the time you're going to round. So we're going to type that in, and I get that y equals 9.397. So we round to the nearest thousandths most of the time. So this side would equal 9.397. And you can test Pythagorean theorem on that. It's going to work. 20 is the smallest angle. This needs to be the smallest side. This would be a 70-degree corner. You know that's going to be the next biggest. We know that 10 is the overall biggest. It needs to be logical when you're done. Okay, let's do another example. So let's say you have a right triangle, and let's do a different angle. Let's say it's 40 degrees. I don't care what the ratio is, just knowing what to do. Let's say we don't know the hypotenuse, but we know that this side is 10. How would we solve for the hypotenuse? Well, we identify the angle we're working on. 40 degrees is the angle we know, so we use the 40. How does the 10 relate to the 40? It is the adjacent leg. How does the x relate? It is the hypotenuse. So we have adjacent leg and hypotenuse. The thing we have, adjacent leg. The thing we want, hypotenuse. So that's the ka part of Sohcahtoa. Ka! That's the cosine of the angle is adjacent over hypotenuse. So we know that the cosine of 40 degrees, that's our angle, equals the adjacent leg over the hypotenuse. Now you can type in cosine 40 if you want to take a look at it. It's the decimal 0.7660. I don't expect you to know that, but that's what it is. But what we're saying is that 10 divided by something has to equal 0.7660. That's what it has to equal. How do we solve that? Okay, sidebar, algebra 1. Let's say you had 7 equals 10 over x. How would you solve that? You would multiply the x to both sides. You get 7x equals 10. You would divide both sides by 7. You would get x equals 10 over 7. That's what you would do. Here's a little shortcut. These two spots are going to swap positions every time. So what if it was 3 equals 11 over x? These two spots are going to switch positions. So x would equal 11 over 3. You can do it the long way, but I promise you it's going to look like this every time. If x is down low, they switch places, you know. Let's go. So again, this is the number 0.7660, but I don't want you thinking about it like that necessarily, but this whole thing is the number. It's not the 40. No. Cosine 40 is the ratio, not 40. It is not whole number 40. It is a decimal. It is not a whole number. So it's these two things. They're going to switch places. If x is down low, they switch places, you know. So it's going to be 10 divided by the cosine 40. And I know I said you can't leave decimals in the denominator. We are not going to learn how to fix that right now. We're just not going to fix it. We're just going to leave it like that. So we leave it like that. That actually is the answer. But if I go to the calculator and type in 10 divided by the cosine of 40, round to the nearest thousandths, I would get 13.054. And that is the hypotenuse. It had to be more than 10. We knew that. If it wasn't more than 10, we know we messed up. We know we messed up. Let's do one more. Let's do another one. So let's say that we have, I don't know, I'm just making stuff up. 50 degrees. Nope, we just kind of, let's do this one. Let's do 11 degrees. And we know that this is 7 and this is x. So what do we have? First job every time, identify the angle you're working on, 11 degrees. How do the two sides relate? The side we have is opposite. The side we want is adjacent. What is the oa part of the saying? Sohcahtoa. So it is the tangent of the angle equals opposite over adjacent. So the tangent of the 11-degree angle equals opposite 7 over adjacent x. This is a number. I don't know what number it is. I don't care. But it is the ratio between opposite and adjacent. If x is down low, they switch places, you know. Let's go. So it's going to look like this. That is the answer, but most of the time you're going to type it in and get the decimal. You type that in and get the decimal, you get 36.012. That is how long this side is. And think about it, if that's 11, isn't this 79? Isn't 79 a lot bigger than 11? Isn't this going to be a much longer side? Yeah, has to make sense. All right. So hopefully you kind of understand trig. You understand how to use the ratios to find missing sides. You understand what the ratios are. We're going to throw one more thing at you. How about if the angle is the missing piece? So last thing we're doing right now, let's say we have a right angle. Oops. And let's say you don't know this angle, but you know that this side is 10 and this side is 13. Okay? That's what we know. So let's think about what we could set up. We have this angle. We know the opposite and the hypotenuse. So what is the opposite hypotenuse part of the saying? That's the Sohcahtoa. That means that the sine of the angle equals opposite over hypotenuse. Let's fill in the parts we have. The angle is the missing part. So we say the sine of x equals 10 divided by 13. Guys, this is the ratio. If we know every ratio that exists, don't you think we can work backwards and figure out what angle has to have that ratio? And that's what's going on here. So we're going to do something called an inverse. Inverse has lots of different meanings. Inverse does not just mean reciprocal. Depends on what you're doing. X plus 7 equals 10. What's the inverse of plus 7? It's minus 7. That's an inverse when you're adding. How do we get, what if we have like, 7x equals 10, multiplying? Well, times 1/7 times 1/7, that's undoing. That's the inverse when you are multiplying. But how do you undo like a formula? Or like, sine is like a formula. I actually don't even know the formula. Never learned it. But here's the thing, like if I said like the sine of 20, right, like we did earlier, if I type in sine 20, the calculator does some formula and it produces 0.3420. But what if we had this number? How could we tell the calculator to go backwards? How could we undo that? So what does the inverse look like? That's my question. So this is what we do. It's called inverse sine. We do the inverse sine of both sides. And if you do the inverse sine of one side, you have to do the inverse sine of the other side. And what happens is inverse sine cancels out sine. You're left with just x. That's how you get x all by itself. And then you have to type in the inverse sine of 10/13 in this case. Find this key on your calculator. It's hidden. Well, I don't know. It's there. I don't know if it's hidden. I can find it. Look. Most calculators, you have a sine key, and on the same key, you have the inverse sine. Cosine, inverse cosine. Tangent, inverse tangent. So I have to hit the shift key, sine, and that brings up inverse sine. And now if I do inverse sine, like for instance, let's look at this one. What if I did the inverse sine of this ratio? What if I typed in 0.3420? Ooh, what is the inverse sine? It's 19.9. Why is it not exactly 20? Because I rounded some. What if I go back up? What if I type in more numbers there? 20, what if I made like 201? Is it going to get even closer? Yeah. If I type them all in, it's going to be exactly 20 degrees. So for ours, we're going to do the inverse sine of 10/13. That's our angle. So the inverse sine, so x equals the inverse sine. Oh, I already wrote that down. Inverse sine of 10/13 is 50.283 degrees. That's the angle that produces this ratio of 10/13. If you type in sine of 50.283, if you were to type that in, type this whole thing in, you would get roughly whatever 10 divided by 13 is. All right, let's do another one here real quick. So we got a right triangle. Sorry about the announcements. We got a right triangle here. Let's say we don't know the angle, and we know that this side is 5 and this side is 12. Let's do a real famous one, 5, 12, 13. We know that angle. So let's figure out what we have. We have opposite and adjacent. That is opposite and adjacent. That's the OA part of Sohcahtoa. So tangent of theta equals opposite over adjacent. So the tangent of x, we don't know the angle, has to equal opposite over adjacent. How do we undo tangent? We do the inverse tangent of 5/12. So if I have a tangent over here, in order to get rid of it, I don't divide by tangent. That's not a thing. I do inverse tangent. It goes away. But if I do inverse tangent to one side, I have to do it to both sides. This is the answer, right? If you don't have a calculator, you just leave it like that. But I'm going to type it in, inverse tangent of 5/12. And I know that that angle must be 22.6. Ooh, let's look at this one real quick. People mess this up all the time. 22.6198. We're rounding to the nearest thousandths. So if I need to round to this spot, what would the 8 do to the 9? It would bump it up. So that would bump this spot up. So it's going to be 0.620. Basically, we're rounding 19 up to 20 if you want to think about it like that. You need to be good at rounding. So this is 22.620. And that's how big that angle must be. Again, if you type in the tangent of 22.620. Let's just do that real quick. Tangent of 22.620. If I type that in, let's look at it. Tangent of 22.620. Look at that. Well, what is 5 divided by 12? Boom. Why is it a little bit different? Going back up here, I rounded. But a 22.620 degree angle must have a ratio of 5 over 12. Has to. Every single one of them does. Because every triangle with those angles is similar. They're going to have the same ratios. So there you go. There's the lesson, guys. We're going to talk a lot more about this. The problems are going to get much harder, pretty fast. We have to be really good at these properties before we can move on. Thanks for listening.